4 reactors currently under construction in Finland, as I mentioned, in France, and 2 in China, in Taishan. Each of those projects have moved along. I would say the France project has had some delays, as has the Finland. The China projects are moving at a significantly improved pace as compared to the first 2 movers. And we are also taking those lessons learned and incorporating them in the U.S. The reactor, from the standpoint of safety, initially, when our reactor was designed, we took a lot of questions around how big it was, how maybe it was too safe, it was over-designed, and then Fukushima happened. You know, there was a lot of questions around the EPR. And then out of Fukushima, I think there's still questions that we need to address, but I think some of the robustness of the EPR has shown through to be pretty well thought out. Ultimately, each reactor will go through its own evaluation from the design certification in the U.S., and there'll be a post-Fukushima requirements, clearly. But we believe some of the things that we've done in the EPR bode well for our plant and demonstrate what the original thoughts were in the reactor. The other things that are important to mention is not only the undergoing certification in the U.S., which I'll talk about briefly, is that we have taken lessons learned not only from OL3 in Finland and in France and in China, and we've already incorporated those in what we envision to be the deployment of the technology in the U.S. And we've done that with our partners at EDF and Bechtel, and looked at the reactor very closely so that the first deployment and then any new initial deployments made worldwide will take this, what we call an optimization view of the reactor, and you get the benefit of that. And they're tangible. I cannot quote numbers, I'm not allowed to, but they're tangible improvements, and they're being utilized and incorporated in EDF, I think, for the UK deployment, and I think they'll be used elsewhere. That is a pretty significant hurdle, and I'll talk a little bit about what that meant. U.S. design certification, these are the phases. The other technology providers know these phases well. It's an arduous process. It's very detailed. It requires lots of challenges of organizations. We started later than the other technology providers. We submitted for design certification later than others. Right now, our rulemaking date is mid-2013. We know exactly what we have left to do, and we have a path to go do that. You know, I applaud the other reactor designers, as Westinghouse is ultimately going to be certified, and ESBWR, et cetera. The amount of work that's involved to do this and the accomplishment of getting that design certification is significant. And we are also under certification processes worldwide. I'm not going to go through these in detail today, but the activities in the U.S. have definitely helped with those activities as we move forward. Things that are, you know, let's talk about reality of the world, but also things in the U.S. Right now are slower than initially envisioned. However, we have 2 combined operating licensing activities, one with Calvert Cliffs, which is now Unistar owned, which is actually 100% owned by EDF, and then also with a company called Pennsylvania Power and Light, and they have a COLA in Bell Bend. And there is an anticipation that we may start environmental activities on 9 Mile Point, which will also be owned, and that site will be owned by EDF as they've taken over the model there. So there are activities. However, at this point, we are not moving forward in any great detail with furthering the detailed design on the reactor because these facilities, the first 2, and to briefly talk about it, operate in a merchant market in the U.S. where power prices are subject to a bidding scenario. And I think I would have welcomed to a regulatory model that Westinghouse is deploying its technology at 2 of its sites. It's a regulated model where you get a guaranteed rate of return. You have to show it's prudent, but you're not subject, the utility is not subject to market prices, which makes a significant investment, which a nuclear reactor is, whether it's $2 or $4, it's got a higher risk to it. there's a benefit to being in a regulated market where you're deploying your technology. And that's, I think that's one of the good reasons for their technology moving forward, in addition to others that were chosen. So I think that's important to know. The market has made a lot of changes in the U.S. The optimization study, and I think, maybe a month or so ago, this was actually quoted by Luc Roussel, where we're undergoing an optimization study review with EDF in France. They're going to be taking this optimization study that we completed about the EPR and incorporating it. It's basically a 150-page report of lessons learned incorporated into one document. And it looks at a number of things that have been learned through construction at OL3 in France, and things that we openly see that once we get our design certification, that we would probably go back and pursue an amendment to that. We're not going to hold up our existing design certification in the U.S. for these activities. The improvement in schedule and costs are, from a cost standpoint, I would argue pretty significant. From a schedule standpoint, I would tell you that they're minimal, but there's definitely improvement. It looked at everything about the reactor and its deployment, and I think you can only get these lessons learned, true lessons learned, if you're building things and you're doing things. Paper lessons learned are just that. I would tell you your initial cost and schedule to build a reactor is paper, until you actually go and do it, and then you learn. So I think this is an important step that we've made in just the past few months, and this will create, I think, worldwide benefit for the deployment of a reactor, that every country who gets it will see the benefit of these activities. Fukushima. You've seen a lot about Fukushima today. You've heard a lot about Fukushima today. This was, I would say, significantly addressed yesterday by the gentleman I mentioned. But we are clearly looking at this. We do recognize that there will be, at some point in time, once it's resolved, post-Fukushima requirements put on for reactors. Not only, although they've been silent on new reactor designs and focused on the operating plants in the U.S., but even the new reactor designs will ultimately be asked to address these questions, and we're looking at that. So we understand it. There's, the active versus passive scenario. We believe there's credible arguments for our reactor, and that's what was addressed yesterday. And I think there's safety features in our plant that were once reviewed as maybe a bit redundant and now are viewed as significant to Fukushima events. In summary, I wanted to just provide you today an overview of Areva, where we're deployed and where that we are actively engaged worldwide. Our evolutionary pressurized reactor is what we will continue to move forward with. We have other designs, the ATME and Karina, that are not nearly as far along as the EPR, and that we really push for heavily in the nuclear side, but also a renewable portfolio. And we really look forward to supplying our products worldwide as we do. And we are excited for when the U.S. market moves forward a little bit more rapidly. I think reality is where we are today is just economics. And once those things change, we will. I don't think the envisionment that gas can be baseload forever, or if you just run as baseload, is realistic. But there are a number of factors that will need to be resolved for that to move back on the path that it was. A lot of it's political, a lot of it's not. So I thank you for your time. Hopefully I gave back some of your time. And thank you for letting me come here and speak to you today.